Hello guys, how's it going? Okay, today we start the new unit, the bonding and molecular geometry. Here in this unit, after we finish all the unit test, I'm sending the marks soon on Engage. So in this unit, the new unit, we start talking about the bonding of atoms together and forming compounds. Okay, so in this unit, we will focus on the following: Lewis structure of drawing diagrams for the combining or the combination of atoms together, okay, and VSEPR theory, or the molecular shape and the hybrid orbitals. So two halves: the bonding, the idea of bonding and Lewis structures. Then the VSEPR theory, which explains how the things. Now this says Lewis helps you to understand how the atoms connect together, but VSEPR helps you to understand what kind of arrangement they take. Okay, very good. So I'm sending you these notes on Engage, like every other unit. Okay, so we will focus today on covalent bonding and Lewis structure. Okay, and go. So introducing covalent bonding. What is covalent bonding? How it works? Why the atoms connect together to form this type of bonding? Okay, so bonds involve the electrons in the outer shells of atoms. The question, the right question you ask: why the atoms bond together? Why the atoms bond together? Like, you remember when I told you that all gases except for inert gases like hydrogen, for example, are always its molecule is found and composed of two atoms. The question is, why two atoms? Because hydrogen cannot stay alone. If you know the structure of hydrogen, it is H1. So here, it's very simple structure where one proton and one electron around. This is the structure of hydrogen, okay? Let's see what is the structure of the nearest inert gas. We will find helium, He24, where it has two protons, two neutrons, and two electrons. And this structure, or the structure of inert gases generally, is perfect. Why is it perfect? It is perfect because the last energy level always full or have 8 electrons. The best structure of any atom is to have the last energy level or the last energy shell full of electron or has 8 electrons. If you have 8 electrons in the last energy level, this means this atom is in a perfect structure. Okay, very good. So if we look at the structure of hydrogen, we will find that hydrogen wants to have the structure of the nearest inert gas, since it is a perfect structure. So that's why hydrogen, which has 1 electron, would combine with another hydrogen, 1 electron here, another here, as you see. You see? So if you cover this, you will find hydrogen, this one to the left-hand side has 2 electrons. And if you cover this, the one to the right-hand side has also 2 electrons. So it is almost, by sharing, they have the structure of the nearest inert gas, and all noble gases or inert gases, they have the perfect structure. Perfect structure. Okay, very good. So now this is the question: why atoms form bonds? Because they can't survive by themselves except for inert gases. They need some help, some support to reach the perfect and reach the nearest inert gas structure. Okay, very good. So each shell has a maximum number of electrons that it can hold. Electrons fill the shell's nearest nucleus. First, let's see here. The maximum number of electrons for the first energy level in any atom is 2. The second one, maximum number, is 8. And this is a magical number if the last energy level contains 8 electrons. Okay? So remember that. Noble gases, inert gases. The last shell here holds up to also 8 electrons. Also 8 electrons, and we will figure out this why later. So filled electron shells are very stable. It makes you stable like all noble and inert gases. They travel in single atoms. They need no help. They need no support. Okay. Then, as you see, the atoms of noble gases have completely full outer shells and so are stable. Okay, noble. This reminds me with Jana. Okay, hi Jana. So this makes the noble gases very unreactive. They don't react with any other atom because they need nothing. Okay, so they don't usually form bonds. So the atoms of the other elements have incomplete outer electron shells and so are unstable. Okay, like hydrogen, it's unstable. As it is unstable, it needs to bond with some other atom to complete its electronic structure. And this happens by forming bonds. Now, why do we atoms form bonds? You know now. You are not complete. Not like any noble or inert gas, and all atoms are trying to reach the same perfect structure. Okay. One of the types of these bonds is the covalent bond. Covalent bond, okay? Before I go through the covalent bond, I want you to see this. Okay, let's go here. No. Now, types of bonds. Number 1, ionic bond. Number 2, covalent bond. Number 3, metallic bond. Remember this, very important, that it is the governing rules of the types of bonds. Ionic bonds or ionic bond happens between metal plus non-metal. Covalent bond, 2 or non-metals only. Metallic bond, metals only. Very simple. Ionic bond, it happens between the metal and non-metal. Covalent bond happens between non-metals only. And metallic bond happens between metals. Very good. Now let's return back. We will start with the covalent bond. Let's take chlorine as an example. Okay, chlorine is Cl17. Cl17. So it is 35. Cl17, 35, you can check this in your formula sheet, the periodic table. Cl17, 35. This is the atomic number, and this is the mass number. Okay, we know that. Very good. So from here, the atomic mass 17, this means chlorine has 17 electrons. Okay, how do we put them in shells? Well, it's very simple. I told you. The first energy level, chlorine, the first energy level takes up to 2 electrons. Second one takes up to 8 electrons. Third one takes up to 7. So 2, 8, 7. The last energy level has 7. Let's see this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7. And I told you to get the perfect structure like the nearest inner gas, even if you have the last energy level full or has 8 electrons. So here has 7 electrons. So what does chlorine need to reach the next level? It is having 1 more electron. Okay, very good. So this is chlorine, a chlorine atom, and another chlorine atom. Now, they both think, I'm not perfect, you are not perfect. Why don't we share together to look perfect? And this is exactly what happens. Okay, I have 7 electrons, you have 7 electrons. So each one of them will share with the number of missing electrons. Like I miss an electron to reach the perfect structure. This means I gain an electron, or I share with an electron. Again, chlorine is 287. Chlorine needs 1 electron. Okay? So chlorine will share with another chlorine atom. Very good. But share of how much, how many electrons? It will share with the number it needs. Here, chlorine needs 1 electron, chlorine shares 1 electron. If you need 1 electron, you share 1 electron. If you need 2 electrons, you share 2 electrons. So what happens that the 2 chlorines come together, as you see here. Now, 1, 2, 3, 4, 5, 6, 7 dots, and 1, 2, 3, 4, 5, 6, 7 stars. Stars and dots, when the chlorine atoms come together. Now, this one shares an electron, this one shares an electron. If you cover this one and you count the outer shell or energy level, you will find 8 electrons for this chlorine. And if you cover this one and you count the electrons in the last energy level will give you 8 electrons, and so on. So that's how they combine together. And this is what we call the covalent bond. This is the covalent bond. Okay, so how is a covalent bond drawn? How can we draw a covalent bond? How can we represent it? So as you see, a covalent bond consists of a shared pair of electrons. Shared pair. One from this, an electron from this atom and another one from this atom, both together. They share one from here, one from there. It makes a pair of electrons. Okay, so how can I draw this simply? Draw the covalent bond simply? It's very simple. You write the symbol of the atom Cl and another Cl, then you just put a dash here in the middle. This how you represent a covalent bond, and this what we call a solid line here represents a single covalent bond. Okay guys, this is it for today. Take care, stay safe.